It's one of the oldest names in mining equipment, Marion. More than 100 years ago, Henry Barnhart saw ways to improve the steam shovels of his day. With Edward Huber and George King, he founded the Marion Steam Shovel Company in Marion, Ohio. In the late 1800s, when a network of railroads was built across the United States, Marion was there. Later, when huge amounts of coal were first dug from large surface mines, Marion was there. When thousands of workers cut through the American continent to build the Panamakanaal, Marion was there. And when some of America's biggest hydroelectric projects were built, digging was done by Marion machinery. Much later, Marion even had a role in America's space program, supplying the crawler transporters that are still used today in the space shuttle program. From building 19th century railroads to moving the space shuttle to the launch pad, some of the largest mobile equipment ever built started at the Marion facilities. Today, that equipment includes the draglines, shovels, and drills needed around the world to uncover vital mineral resources. Marion draglines are used to strip millions of tons of overburden. Weighing up to 17 million pounds, these machines have been continually upgraded, utilizing the latest engineering technology. An example of Marion's leadership is this planetary swing system. Utilized on our largest draglines, the entire swing module is located within the rotating frame of the machine and permits greater power to be applied while reducing critical stress on gearing components. In 1991, Marion was granted a patent in recognition of its unique design. Marion offers 8 dragline models, ranging from 10 to 180 cubic yards of bucket capacity to meet virtually every mine's stripping requirements. Marion's 8000 series draglines provide the capacity, productivity, and reliability for the world's largest coal mining operations. Engineering advances have enabled Marion to increase the productivity of comparably sized models by more than 20%, while increasing reliability as well. To supply machines with this level of productivity takes several years of work. It begins with designing to a customer's individual requirements, through manufacturing and a complex erection process. Each step of the way, our experts are there working closely with the mine's personnel to ensure the best machine in the business goes to work on time. Marion's smaller walking drag lines, the 7000 series, are still mammoth by most standards. The 7820 with a 35 to 45 cubic yard bucket has recently been chosen by customers in Australia and India for major new coal mines. And at the small end of the spectrum, Marion offers the 7250, a modular walking dragline designed for quick assembly and disassembly when mine operations may not last as long as the machine itself. Although the unique walking mechanism of our largest draglines provides the mobility most large mines require, in many instances, the added mobility of a crawler machine is needed. Marion's crawler draglines meet this need with the same high productivity of a walking dragline. Marion engineers extended the capacity and reach of these machines with the recent introduction of the world's largest crawler dragline, the 305M. The 305M, now operating in Australia, utilizes a host of engineering innovations, including an energy-saving flywheel system to provide a crawler dragline that's more than 50% larger than any competitor's machine. While the productivity of a walking dragline is unrivaled in direct cast operations, digging and loading ore and overburden requires a different kind of excavating tool, Marion's line of large electric mining shovels. Ranging up to 2.3 million pounds in operating weight, our shovels can handle dipper payloads from 15 to 85 tons while cycling in about 30 seconds. In 1986, years ahead of the competition, Marion commissioned the first mining shovel capable of loading the newest generation of 240-ton trucks in just 3 passes. State-of-the-art features like planetary drives on all motions make the 301M the most advanced and productive shovel in the world. With many units now operating in major mines in the U.S., Canada, and Australia, it sets the industry standard, and Marion engineers have applied advances made on the 301M to other shovel models, including the 204M Super Front shovel. With its unique front-end design, this shovel operates better in low banks or pitched seams. The 201M is a proven match for 120 to 170 ton trucks. The unit shown here is operating in an African uranium mine and incorporates the dual motor lower frame planetary propel pioneered on the 301M. When mine production plans don't require the capacity of Marion's largest shovels, the 191M is frequently the choice. This machine is just one of 23 selected by the Turkish coal enterprise in the mid-1980s. At the small end of our shovel line is the 182M. Its 20-ton payload and proven, reliable design made it the choice of India's largest coal producers as they expand production in the 1990s. As powerful as Marion's shovels and draglines are, mines can improve excavator productivity by first blasting the material to fragment it. Large rotary drills are used to drill blast holes in the rock formation. In the early 1970s, Marion began offering these large blast hole drills to complement our shovels and draglines. These units can drill holes up to 15 inches in diameter, applying 130,000 pounds of force to the drilling bit. When the latest Marion drill was shipped to a South Africa coal producer in 1991, a group of 4 Marion drills shipped to a U.S. copper producer nearly 20 years earlier were still at work after drilling an incredible 22,000 miles of blast holes. While our draglines, shovels, and drills continue to work for mining customers around the world, Marion continues working to ensure their performance. Marion's production facilities contain some of the largest and most sophisticated metalworking equipment in the world. Despite component dimensions measured in feet, tolerances are often measured in thousandths of an inch. Marion employs a variety of testing techniques to provide the quality assurance needed to make Marion machines perform to the highest standards. The skill, experience, and investment in people and equipment that goes into building our machines in the first place are also applied to the job of keeping them running. An excellent example of this is the Marion right weight bucket. Our knowledge in dragline design and experience working with customers around the world are applied to a line of dragline buckets that maximize machine performance. This doesn't always mean the largest capacity bucket, but one that can stand up to a particular mine's digging conditions, minimize downtime, and handle the load for which the Marion dragline was designed and built. Any machine that's expected to operate as much as 8,000 hours a year needs a full range of parts and service support, and we strive to provide the best in the business. Marion produces replacement parts to the same standards as the new equipment and often incorporates design or manufacturing improvements to make our replacement parts even better than the original. And Marion stocks a multi-million-dollar inventory in strategic locations around the world. Our parts manufacturing program includes the rebuilding of major components supplied by the customer at a fraction of the cost of a new part. When done by Marion, these rebuilds get the same new parts warranty for all material and workmanship provided. When field support is needed, Marion is there. Trained field specialists have the most advanced equipment available to assist mine operating and maintenance people. Field machining, boom raising and lowering, machine relocation, inspection programs, and a host of other service functions are provided by Marion's Customer Service Department, with the full support of the entire Marion organization. From the first sales contact to the day a Marion machine goes to work, year after productive year, everything Marion does is focused on helping our customers produce efficiently, reliably, and cost-effectively.